5509, so you have the RFID, of course. You know, ISM band 902 to 928 is, there's a lot in there. So the 802.11, what's Halo? Halo is 802.11H? Maybe. Anyway, I've had good success with, I've recommended it to several customers. I worked very closely with one customer in the Halo, on his Halo design. We eval board, his board back, working on his board in our lab, and we were able to successfully implement GRF5509. Oddly enough, 802.11AH is what it is. He moved on to his next design, and GRF5611, 10 or 11, did better. And actually, his company put out a press release that they broke a range record with it, with our device in there. So, you know, 5509 does fine there, but we may have found one of our devices that does even better. 5509 just for the general purpose stuff. I'd have to go and refresh a little bit, but for the multitude of applications in that band where it's just being looked at, I'm always sampling it, and there's always new applications coming in for it. It's just sometimes have a hard time coming up with the specifics. The best things about it are, you can get 4 watts out of it at high efficiency, and you're thermally fine. You can back it off and linearize it so that it behaves somewhat like GRF5510 or some of our other linear PAs. So you can run it in nonlinear fashion. You can back it off and linearize it with bias adjustment. You know, the V-enable 2, the V-enable 1 and V-enable 2 bias lines enable you to do a lot with it. And because 5504 has been able to do it, its sister part, its 450 megahertz sister part, GR5509 will accommodate power control too. Not perfectly like the old GSM PAs that were like linear with VAPC, we had linear power control, but you can hit 5509 or 5504 with a high input drive level to 0 dBm, and then you can ramp V-enable 1 and or V-enable 2 for power control. So right there, it can fit into all kinds of applications. The main one is the R5110G, which, because I know a lot about it, was an older GSM PA designed by a guy we all knew, had to be brutally rugged into a 10-to-1 Visuar because that was the spec for GSM, right? So it was super rugged, and it had you get 4 watts out of it CW. So it was high gain. Turned out we figured out that you could tune it all over the place, so it was perfect for RFID, and it went EOL, which opens up opportunities for us. There are some other ones too that have gone EOL, and which but I can't, they don't, because they don't. Oh, well, I know there's one. Is it okay to mention manufacturers? We were talking about it today in our meeting of Avago had a big linear PA that was used for RFID that just went EOL as far as I know. So that happens. That happens, and you know all too well that opens up opportunities for us because none of our stuff goes EOL. we have no EOL. Tips or tricks? Well, it's like this. Okay, so say we're going out of band. Some people I've had requests for 750 megahertz. Okay, take the S parameters, small signal S parameters, put them into ADS, model the eval board with substrate components, all that stuff, traces, simulate a small signal matching response, then go build the board. Then, if it's close, bring it in, then run then match the output, okay? Output matching, for me, over time has become somewhat instinctive, but, generally speaking, you have an idea what load impedance you want, via simulation or otherwise, set that load impedance, get it on the bench, and then I want to do iterations. Customers will sometimes ask me, we're not making power. Could be for a myriad of reasons. And oftentimes during that discussion, I'll say, change these two capacitor values because the basics are, if you want to go higher in frequency, you lower the value of the cap. If you want to go lower in frequency, you increase the value of the cap. So that's fundamental stuff. So I give them some fundamental directives and say, try this, try that, get back to me, see how it goes. If things get really tough, I'll have them send me their board and we'll match their board for them. So depending on the questions, but I draft documents that are pretty thorough and I send it to the customer. Try this, do that, do that. Yeah. One thing that you got to look out for is with any of these devices that are above 2 watts, you have to use an RF choke that can handle the current. It can handle the current, and if it can handle a lot of current, it has a low series resistance, so you don't get a lot of drop and you don't kill your efficiency or compression point. If you have a series inductor in the output match, it has to be robust enough to handle the power. Because we've gone into thermal scan, IR scan, and we find out that our little series inductor on the output is lighting up and getting hotter than the die because it's too small. So I just had a conversation with a customer along those lines where he said, I asked him, what size series inductor are you using in your output match? And he said, come back to me and say, why does it matter? I said, well, here's why it matters. If it's 0402 and the wires are too thin, could be a problem. So that's why I use 0603. Good question, but that's why. So that's sensitive. The only other, sometimes you'll find that, not necessarily with these parts, but you'll find that decoupling capacitors near the pin on the V-enable lines make a difference. Matter of fact, they make a difference on the 5603. I specifically experimented and determined capacitors that need to be on the 5603 V-enable lines. We already talked about the ones that had to be on the supply line. So every PA is different. Every PA is different, and during the learning process, you have to try these things to find out, because what matters with one won't matter at all with the other ones. So you can't make assumptions. Matter of fact, I'm tuning one up today. I'm trying to get more efficiency out of it, and I tried the harmonic, the choke harmonic thing that you talked about didn't work, but I'm trying impedance terminations off the pins to see if I can increase the efficiency, because that's what the customer cares about. We're trying to knock out a competitor, which might be an end of life too. So that happens all the time. It's not causing problems, because if you really what matters is what comes back from the field. Okay, it's not bulletproof. It's not bulletproof, nor is 5504, but they're not problematic per se. But very few PAs are bulletproof. So you're going to see issues from time to time, but I wouldn't call it an Achilles heel on either one of them. It's got a long history. It's going to have a long future going forward. I believe it is. And so over time, who knows? It could become dominant. We'll see.
Cool.
Yeah.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.